is your 1 0, this coordinate was 1 0, this was 1 1, means it is a square. Okay.
Okay.
So now this is A dash, it is PQ, this is P, this is 1. So cos theta is P by 1. So P is cos theta, isn't it? Sin theta is Q by 1.
Yes.
So Q is sin theta. Okay. So now you can see the image of 1 0 is cos theta and sin theta. Okay. Got it? Hello.
Okay. Yes, sir.
Are you getting
And what
it?
about the B dash, sir? What's the?
Okay, let us calculate beta also, B dash also. So what will be B dash? This distance is 1. Okay.
Okay.
Let us say this is E. So what is cos theta? Cos theta is OE divided by OB dash. Okay.
Okay.
Now what is OE? OE is OB dash is 1. So OE is cos theta, isn't it? Okay.
So E is cos theta. Okay.
Okay. What is B dash E? Similarly, B dash E we can say it is sin theta, isn't it?
B dash E is sin theta. Yes.
Okay. So what will be the coordinate of B dash? This is cos theta and this is sin theta. So what will be the coordinate of B dash?
Okay. So minus sin theta.
Minus sin theta cos theta.
So minus sin theta.
So B dash will be minus sin theta cos theta. Okay.
Okay. So that's the same as what.
So if
that's the same as what's in the text. So cos theta, sin theta.
So if this is PQ, so this B dash, let us say it is P. So P is cos theta and Q is sin theta. So this becomes minus QP. Okay. You can say it is minus
QP. Okay.
Okay. So like this you can find out its image.
Okay. So why isn't it minus PQ?
Minus QP.
Okay. So why isn't it minus PQ?
Sorry. Because
Why isn't it?
Because P is cos theta. So if you put cos theta as P, so that will become P, and Q is sin theta, so minus sin theta will be minus Q. Okay.
Okay, because initially we thought it was minus PQ, sir. So how do we find out without saying?
No. That was wrong. That was wrong. Okay. This is right.
Okay. Because without finding cos theta is P and sin theta is Q, how could we find
we can't. We have to find it. Okay. Got it now?
Okay, yes, sir.
So image of A is cos theta sin theta. Image of B is minus sin theta cos theta.
Cos theta, okay.
So what will be your transformation vector? Transformation matrix?
It will be cos theta sin theta.
Initially it was 1 0. Sorry, it was 1 0 and 0 1. Okay. If I rotate it theta degree anti-clockwise, so what its transformation? 1 0. The image of 1 0 is cos theta sin theta, isn't it?
Yes, sir.
And the image of B is minus sin theta cos theta.
Okay.
Got it now?
Yes, sir. Got it.
So the image of point A is cos theta sin theta and the image of point B is minus sin theta cos theta. So your transformation matrix is cos theta sin theta minus sin theta cos theta. Okay. Now what happens if you are rotating it by 60 degrees? So that means it becomes now your formula. Okay.
Oh, okay.
It becomes your formula now. If you are rotating it anti-clockwise, so it will be cos theta sin theta minus sin theta cos theta. So if you just put the value of theta here, so you can find the matrix directly. Okay.
Okay.
Got it now? Just you please note it down.
Yes, sir. Okay.
And if you forget it, you just can easily calculate it also, isn't it?
Yes, sir.
Because there is a way to calculate it.
Okay, done, sir.
Okay. So if you rotate it anti-clockwise by 60 degree, so that will become, this transformation is becoming 1 by 2 root 3 by 2. What matrix would represent rotation through angle theta clockwise? Okay, can you calculate it now? What
Okay, sir,
happens?
let me,
What happens if it is rotated clockwise? Now what will be its transformation vector? Just do it like this only, whatever we did previously. Done?
Yes, sir. Yeah, I think that should be done. Yeah.
Okay. So what is transformation matrix?
Okay, so sir, I got cos theta minus sin theta cos theta.
Okay. So what is change? Cos theta and?
So cos theta minus sin theta cos theta.
Okay, so that minus sign is here only. So that is only a change. Okay.
Okay. So this is the transformation in the matrix, right? Theta clockwise.
Yeah. So investigate the effect of the matrices. So you could use geometrical software to try different values of m and n. Okay.
Okay.
Describe the general transformation represented by the matrices. Okay, now this matrix, can you describe its? It is, I think it is a stretching.
Yes, a stretch.
Okay, stretching on x-axis.
The first one is stretching on x.
Okay, second one is stretching on y-axis. Okay.
Y, yes.
So now the matrix represents a stretch of scale m parallel to the x-axis. Exactly, I told you the same thing. The matrix, this one represents a stretch of scale factor m parallel to the y-axis. Okay.
So I just have a quick question.
Yeah.
Rotation theta anti-clockwise. I think they said in the question that rotation by theta assumes it's anti-clockwise, right, unless told otherwise. So rotation theta anti-clockwise, we got cos theta sin theta minus sin theta cos theta.
Yes.
I think also I checked. Yeah, so all that happens when we rotate theta clockwise is that it becomes cos theta and minus sin theta cos theta. So just like you said, sir, both the cos thetas remain the same. Just the sign changes in sin theta.
Yeah, only
but
sign. Only
there's also one more way. There's also one more way, sir. The theta anti-clockwise is cos theta sin theta minus sin theta cos theta, and instead for clockwise we can change theta to minus theta, so it becomes cos of minus theta, sin of minus theta, and like that.
Yeah, yeah, you are right. You are right. You are right.
Can we do that?
Yeah, please. You are right. Okay, because if theta is minus theta, so we can replace it also. So cos will not be affected. Only sin will be affected. Okay.
Okay, right.
So that's why just the sign of sin theta will change. Only the sign of sin theta will change. Cos theta will not be changing. Okay.
Okay.
Okay, now shears, figure 1.20. Where is 1.20? The matrix
Oh,
transformation.
it's at the bottom, sir. It's at the very bottom.
Okay, so shows the unit square and its image under the transformation represented by the matrix 1031 on the unit square, the matrix vector to the vector 10 and transforms the to the vector 31. Okay, now the point with position vector 11 is transformed to the point with the position vector 41. Okay. Okay, now we can see this. This was your original matrix. Okay, this was the point 10, this was the point 01. So, and this was the point P. So now you can check it. Your point P is now become P dash after transformation, and this J becomes J dash. So this is going with an angle. Okay.
Okay.
So this is called shear. Okay.
Okay.
This is called as shears. Your whole matrix is getting changed, like it has some rotation. Okay.
Oh, okay.
So this is called as shears. This is an example only. We'll see it. So this transformation is called a shear. Notice that the point on the x-axis stays the same and the point J and P move parallel to the x-axis to the right. This shear can be described fully by saying that the x-axis is fixed and giving the image of one point not on the x-axis. That is, you can say your point 01 is mapped to 31. Okay, it is neither on x-axis nor on y-axis. It was on y-axis, it is not on axis. Okay, so
Okay.
if your point is mapped, your axis point is mapped on not on axis, so then it is said to be shear. Okay, got it?
Okay.
Okay, now generally a shear with the x-axis
Yes,
fixed has the form like it was 10 K1 and the shear with the y-axis fixed. So now here we have fixed x-axis. Okay,
Okay.
and if the y-axis is fixed, so now your x part will be 0 here. Y-axis is fixed, so your x part will be 0. Okay,
Okay.
here your x-axis is fixed, so your y part is 0. Got it?
So a shear with the x-axis means the x-axis is fixed, or
Yeah, shear
Okay.
with the x-axis fixed. X-axis fixed. X-axis will be fixed. Okay, we'll see it in examples. It will be clear. No issues. So now this is your example. Find the image of the rectangle with the vertices. A is this one, B is this one, C is this one, and D is this one under the shear. So it is just a shear. Okay.
Okay.
And show the rectangle and its image on a diagram.
Okay.
So first of all, you need to find its image with -1 2. Okay. And 1 with 1 2, with 1 -1, and with -1 -1. So you will get it. If you find its image on -1 2, you will get it 5 2. Okay.
Okay.
And you can notate it by this. So image of -1 2, if you multiply these two matrices, if you multiply 1 1 0 3 1 with -1 2, so what you get? -1 plus 6, 0 plus 2. Okay, so it will be 5 2. So image of -1 2 is 5 2 with the shears 1 0 3 1. So this is its image. Okay,
Okay.
and the image of 1 2 will be 7 2. Image of 1 -1 is this one. Image of this one will be this one. Now you can denote these images on axis. Okay,
Okay.
Now this one you can see here. Okay, so if you denote these points, this was A, B, C and D. So image of A was, image of A is phi 2. Where is phi 2? Phi 2, phi 2, phi 2 is this one. Okay, it is 7 2, 7 2 will be this one, minus 2 1, minus 2 1 will be this one, and it will be minus 4 minus 1. Got it?
Okay, yes sir.
Getting it now?
Yes sir, correct.
Okay. So the effect of this shear
Sir,
is, yeah, please.
Sorry. I noticed one more thing, sir. This is the example we just did is a shear with the x-axis. Shear with the x-axis means the x coordinates. Because in this example, sir, it wasn't OABC. There wasn't any coordinate on the origin or on the x-axis, so we couldn't see. But the points a dash, b dash, like the lengths, the length a dash, b dash, and c dash, d dash are the same.
See, this was your shear 1031. So what it is notating? It is just denoting that your y coordinate is 0. That means it is x axis is fixed. Okay, so you can recognize it. You can recognize it by this 0. Okay, in this your y coordinate is 0, so that means it is fixed at x axis.
Okay.
By this way also you can recognize it. Okay.
Okay. And so a dash, b dash, and a dash, b dash, and c dash, d dash are the same as a, b, and d, c.
Same means?
They're the same length. Like for example, the y coordinates get stretched, but a dash, b dash, and c dash, d dash, x coordinate wise, distance wise are the same. They're 2 units.
Yeah. That means x axis is fixed.
Yes, sir.
Okay. Got it?
Yes,
You can easily recognize by the shear also. By the shear matrix you can easily recognize it. Okay.
Okay.
So notice that under the shear transformation, points above the x-axis move to the right and the point below the x-axis move to the left, but its length will remain same. The effect of this shear is to transform the sides of the rectangle parallel to the y-axis into sloping lines. Notice that the gradient of the side a dash d dash is 1/3, which is the reciprocal of the top right hand element of the matrix. Okay, that means here also you can see that gradient of a dash d dash is 1/3. That means which is the reciprocal of the top right hand element of the matrix. Okay.
Okay.
So these things you must write it down, because by recognizing itself you can find the things. Okay, just write it down, this thing.
Okay. Okay, sir.
So these are some properties of shear transformation. Okay.
Okay.
Noted?
Okay. So should I just write down everything I've done so far? For example, all the general transformations, shear, stretch, rotation.
Yeah, you have to make notes of all that.
Okay.
Okay. After this class, please summarize it, everything.
Okay.
Okay. I think you are making notes of all, whatever you are studying. So making notes is very good, because it is easy to summarize. Okay. Make it in your own words. Okay. So in shear transformation, you find 2 or 3 things. How to recognize the shear transformation. Okay. What will be the gradient of your A dash D dash? You can easily find out. Okay,
Okay.
these things will be used in questions. Now for each of the points A, B, C and D in example 1.7, find distance between the point and its image upon the distance of original point from x-axis. Can you please find it? Distance between the points and its image. That means this A dash, B dash, C dash, D dash. Can you find it?
Okay.
Okay, this was the point, -1 to phi 2. So what is the distance? Distance is 6. Between these points,
Okay.
distance is 6. Between these points, 7 minus 1 is 6. So again it is 6.
Again it's 6.
1 plus 2 is 3 and it is cancelled. It is 3.
Okay.
Again it is 3. Okay.
Okay.
So A to A dash 6, B dash 6, C dash 3, D dash 3.
3.
Okay. And the distance of original point from x-axis. Distance of original point from x-axis. From x-axis it is how much? 2. Isn't it? 2,
Oh, yes, sir.
2 to minus 1. Oh, sorry, from origin, I think it is saying from origin.
From origin.
Distance of original point from x-axis. Yeah, it is 2 and 1. Okay.
Okay.
So what you noticed?
So it's always that, sir. So it's
It is in the ratio. It was 6 3. It was 2 1 2 1. So the ratio will remain same. Okay.
So, sir, but isn't the ratio changing? Because distance for between the point and its image. So B dash and C dash, A dash and B dash are so the 6. Oh, from distance between the point and its image. So 6 6 3 3. 6 divided by distance of original point. 6 divided by 1 6. 6 divided by 1 6. Distance of original point from x-axis. Then D dash, C dash are 3. The distance of original point is 1 and 1, so 3 and 3.
Yes. Okay.
So what do we notice, sir?
So the ratio will remain same. 6 divided by 2, 3 divided by 1.
Why is it 6 divided by 2, sir?
Okay, we'll see it later on. So in the activity on the previous page, you should have found that dividing the distance between the point and its image by the distance of the original point from the x-axis, which is fixed, give the answer 3. Every time it is 3. It is fixed.
Oh, it's 3. Why is it? Sorry, let's look at why it's 3. Because didn't we get 6 divided by 2 is 3?
6,
then didn't we get
6 divided by 2 is 3. 6 divided by C.
3 divided by...
Distance between A dash is 6. Okay.
Yeah.
A dash distance is 6, and how much above it is from x-axis? It is 2 point, so you get it 3. Distance between B and B dash is 6, and how much above it is from x-axis? It is 2, you get it 3. Okay.
Okay.
Now distance between D and D dash, you find it 3. How much it is below x-axis? 1, so you'll get it 3. Again with the C point also, C dash is 3 and the distance below x-axis is 1, so you get it 3. Okay. So these are some properties of shear transformation. Got it?
Okay. Yes, sir.
So in the activity on the previous page, you should have found the dividing the distance between the point and its image by the distance of the original point from the x-axis, which is fixed, gives the answer 3 for all points. It is fixed 3 for all points, which is the number in the top right of the matrix. This is called the shear factor, and you can easily recognize it. That was the number written on here, 3. Okay. Got it?
Yes, sir. Got it.
So this 3 is having so many significance. By this 0 you can recognize it. So this and this, these are the two numbers which are very important. Okay.
Okay.
This is gradient also.
Oh yeah, negative. Yeah, the reciprocals.
It is 1 by gradient. Okay.
Okay. And what's the 0 for, sir? Why is 0 important?
0 is showing you, if this is on y axis, then x axis is fixed.
Oh, okay.
Okay. If this is on x axis, your y axis is fixed. Got it?
Okay, yes, I got it.
If it is like this, this means y axis is fixed. Okay.
Okay.
Got it now?
Yes, I got it.
So there are different conventions about the sign of a shear factor, and for this reason shear factor are not used to define a shear in this book. It is possible to show the effect of matrix transformation using some geometrical computer software packages. You might find that some packages use different approaches towards shear and define them in different ways. Okay. So in your book, this shear will be you will not do it in your notebook. It will be done by software only. Okay.
Okay.
So in a shear, as the y-axis is fixed and the image of the point 10 is 0.15, draw a diagram showing the image of the unit square under the transformation S. Find the matrix that represents the shear S. Okay, just can you do this example?
Okay.
In a shear S, y-axis is fixed now, and the image of point 10 is 15.
Okay.
You have to take a unit square. Okay.
Okay.
Have you found the Shear matrix?
Just looking at it, because the original one would be ABC, but it says the y-axis is fixed, so the image of the point 1, 0 is 1, 5. So okay, image of the point 1, 0. Oh, 1, 0. Yeah, that's fine. 1, 0 is 1. Oh, okay, no. 1, 5. So up here. 1, 5 is there, and this is A dash.
Shear matrix if y-axis is fixed. It is like this.
Yes, sir. If y-axis is fixed, it has to be of the forms, yeah.
So it is 1, 5. The image of 1, 0 is 1, 5, and this 0, 1 will remain like this only. So that will be your shear matrix.
Because how shear is means y-axis is fixed means all the points will remain on y-axis. Okay.
Y-axis fixed means 0, 1 will give you the same.
Oh, 0, 1 will give the same. Okay.
Okay. So 1, 0 is giving you 1, 5. That will be its first column, and if it is fixed at y-axis, so 0, 1 will give you 0, 1 only.
Okay. Okay, got it, sir.
Got it?
Yes.
So what will be a shear matrix? It will be 1, 5 and 0, 1.
0.
Okay.
Okay.
So this was all about two-dimensional transformation, and that all was linear transformation. Okay.
Okay.
This is very beautifully written in your book. Summary of the transformation in two dimension.
Yeah.
Okay. If there is a reflection in the x-axis, so 1, 0 will give you minus 1, 0, and 0, minus 1 will give you 0, 1. Okay.
Okay.
Reflection in the line y equal to x, so your 1 and minus 1 will become 1 and 1 will become minus 1 and minus 1. Okay.
Okay.
If it is a rotation, you will get it cos theta sin theta minus sin theta cos theta. If it is an enlargement, you will get it both k on diagonal by the scale factor k. Okay.
Okay.
Now it is a stretch parallel to the x-axis, scale factor is k. I think that is very simple. If it is
Yes.
stretch parallel to the y-axis, scale factor k. Okay.
Yes, sir.
Now it is shear. X-axis fixed, so 1, 0 k1, and if y-axis fixed, it will be 1 k 0, 1. Okay.
Okay.
Now we'll see transformation in 3 dimensions. Do you have any doubt till now?
No, sir.
Okay. So just only introduction, because I have class in 2 minutes.
Okay.
So I need to finish it up. Okay. So we'll see the transformation in 3 dimension in the next chapter, in the next class. So if I am talking about 3 dimensions, so 3 vectors will be there, that is I is the vector, unit vector in direction of x, j is the unit vector in direction of y, and k will be the unit vector in direction of z. Okay.
Okay.
So we'll see 3-dimensional geometry there, 3-dimensional vector representation in matrices. Okay.
Okay. Okay.
Okay. So we'll start from the next class.
Okay.
Okay, Arav.
Yes, sir.
Bye bye. See you on Sunday.
Okay, thanks. See you. Bye.
Bye. Welcome.